This is the interim presentation for ME 452, Team 16, the analysis and redesign of an HVLP spray gun.
Our product is a high-volume, low-pressure paint spraying gun. It's used primarily by professionals in the construction and auto industry to apply paint to various surfaces. Those will be our primary customers. Our secondary customers will be amateurs who enjoy painting personal projects, whether it be personally made furniture or their own cars, or any artistic projects that they care to engage in. Our estimated annual demand is 110,000 units, and our estimated production volume is 60,000 units.
The core function of our paint gun is to spray paint. The first key functional requirement is it must contain paint. It must also regulate spray by controlling paint flow and controlling the shape of the paint that is being sprayed through the angle and the width, which must both be adjustable. It must assure convenience, which it does by being able to be cleaned and being able to be refilled. It must assure dependability by reducing the amount of times that it jams. It must enhance the product by being easy to refill, and it must please the senses by being comfortable to use.
We found two reasonable assembly patterns, that being both starting with the main body, followed by the container and hanger, the trigger, internal nozzle, and needle as a subassembly installed into the main body, the external nozzle, a larger knob for controlling the paint flow, and then the axle for the trigger and smaller knobs. The other route involves installing the trigger, needle, and internal nozzle assembly first, the axle, and then installing the larger knob and the rest of the individual parts I mentioned before.
Sequence 2 is preferred to sequence 1 as it has a higher score in ease of transferring and handling, ease of fastening and joining, and ease of testing subassemblies.
This is our function component mapping matrix. You'll notice that many of our components contribute to controlling paint flow and enhancing comfort, and that all of our components contribute to at least one function from the FAST diagram.
The full assemblies, as well as their components, are showed in the next few slides, as well as an exploded view that is used to help in the aid of the bill of materials.
This is our bill of materials. As you can see, the main body is by far the most expensive item. However, you have to consider that this is a subassembly of many different components, some of which are found in typical spray gun models but are not included in our CAD model. So we decided to group these components together into a subassembly with the main body, which is why our estimate is so high for the cost. The next two most costly components are the paint container and the internal nozzle. Our total cost to produce comes out to $31.82. Our quad chart shows that the most functionally important and most expensive components are the paint container, main body, internal nozzle, and needle. These components can be focused on for DfMA redesign. The low-cost, low functional importance components could be considered for elimination.
Here we have our functional differentiation table and component commonality table. On the left, we have our functional differentiation table. This table is a tool used to compare the functions of a product between different consumer types. On the left side of the table, you list the key functions that are similar for both primary and secondary consumers. On the other side, you list the functions that are different between the two. In our case, the primary consumers are painting professionals, and secondary consumers are amateurs painting for personal projects. The difference in our two consumer products is the tank size. On the right, we have a component commonality table. A component commonality table is a tool used to identify which components are shared across multiple products or subsystems. The goal of the component commonality table is to help teams standardize designs, reduce inventory costs, and simplify integration. On the left side, you list all the components on the platform level, or components that are shared between entire products. On the right side, you list all components at the module level, which are modular components that are interchangeable and different between similar products.
Within the main body, there are two common interfaces that allow for the assembly of both variants of our product. At the location where the paint tank connects, there's an internal threading that allow for the large tank or the small tank to be screwed in. Similarly, at the location of the knobs, there's internal threading that allow for any size knob to be connected. The assembly sequence of this product can be redesigned to incorporate the different paint containers at the very end. This improves on the efficiency of your assembly sequence as you're only incorporating varying products at the very end while the rest of the body stays the same.